Hey guys, welcome to my channel Code with Kai, and topic for today is binary search recursive. Okay, so we'll just code the solution of binary search recursive since I've already taught you the concept of binary search in previous video. Okay, so this is just a follow up. So and there is also a caveat of binary search we'll discuss in this particular video. Now we are going to start the coding of binary search recursive. Okay, so I have a driver code here and a class in C++. Okay, so since this is a recursive code, what I'll do is I'll set s as 0 and e as array dot size -1, and then I'm going to return, and we're going to call this function solve. So I'm going to make a function. So it takes array, it takes target, it takes start and end indexes. Int solve, okay, which take vector of int passed by reference array, int target, int s, and int e. Okay, the first step is to check if the s and e has overlapped, because there is no way we found a target if this happens. Okay, so if s is greater than e, return -1. Okay, so this is one of a base case. The second base case is if we reach the target. Okay, if int mid is equal to s plus e minus s by 2, so this will give us the mid index. We'll simply check if array of mid equal target. What have we found the target? If it did, we'll return the index of the mid. Okay, otherwise we have two choices. Okay, if uh if the array of mid is greater than target, okay, so whatever is at the center is more than the target. Okay, so that means a target is smaller. So what we'll do is we'll take the e and we'll do mid -1, but we won't do it like normal way. We're going to return from here, since this is a recursive code. So we're going to take array target, and uh, e is going to go to mid -1. So we'll set the s as s and e as mid -1. Okay, otherwise we'll return and we'll do solve array target. Now s is going to be mid +1, and e is going the end pointer is going to point to the same. Okay, so let's try to run this on this particular example. Let's just first do 8 and run it. So 0 1 2 3, so it works. What about 9? Does it exist? It does not exist. Let's go about 2. It should print 0. So that's it. This is the recursive code of binary search. Okay. Okay. So one of the major caveat that we'll face when performing binary search is the calculation of mid. Okay, and the main question that you will find is, why are we using mid as s plus e minus s by 2 everywhere in binary search, and why not we just do uh, s plus e by 2? Okay, to answer this question, first let's understand integer range. In C++, the normal integer range is -2 raised to power 31 to 2 raised to power 31 minus 1. Okay, so this is the integer range, and this would be the int max. Okay, so if we try to perform, suppose s is pointing at int max, that is 2 raised to power 31 minus 1, and e is pointing at suppose 31 minus 2. Okay, or you can make it other way around as well. Okay, so, and if we try to perform a normal mid calculation, s plus e by 2, see the result what we will get. Okay, so this number is more than int max. Okay, so to prove you that, so let me print e. What is e? So this is actually representing the int max at that point. So see, so this is the maximum number int max can hold, and this is the number we are getting after calculating the mid. This is actually going to be mid. So this is the normal way. And if we do the Mentos way, let's say print tweaked, okay, and we do s plus e minus s by 2, okay, and we run it. Let's run it. Did I miss some calculation? Okay, yeah. So tweaked. So the tweaked version will actually work fine. Okay. So here we are saying it is giving the answer in decimal, but in C++ this will be this LHS will be considered. Okay. So this is a safe way to calculate to find mid, and this is an unsafe way to find mid. So see you guys in the next video where we will do more problems on binary search, some of the easy problems, and then we'll move on to the medium problems. That's it. Bye.